we are going to go through some common proportionalities or relations. The first is direct. Then we'll do inverse, inverse square. We'll do square. And finally, we will do square root. Okay. All right, direct. That's when y is proportional to x, and the graph looks like this. Inverse. That's when y is proportional to the inverse of x, and the graph looks kind of like this. Inverse square. That's when y is proportional to the inverse of x squared. And the graph is similar to inverse, just kind of hugs the axes a bit tighter. So maybe we could exaggerate and do it more like this. For inverse and inverse square, the x-axis is an asymptote. You continue to approach the x-axis, but you never get there. Likewise down here. Similarly, the y-axis is also an asymptote that you never quite reach. Next, we have a square relation. That's where y is proportional to x squared. Kind of increases like this, goes through the origin. Then we have square root, where y is proportional to the square root of x. And that's kind of like this, concave down. Now, only when you plot two things that are directly proportional will you get a straight line through the origin. But what if we take this scenario and we modify the x-axis? In particular, what if we plot, instead of y over x, what if we do y against 1 over x? So again, instead of plotting y against x, it's now y against 1 over x. Well, how are these related? Y is proportional to 1 over x. The y and 1 over x are literally directly proportional. So we should get from this a straight line through the origin. This is how you take this data and make it linear. And we are literally, every single data point on this line, we are taking every x coordinate, every x value, and we are taking 1 over that x value and plotting those new values on this graph. Okay, what do we have to plot to get a linear graph when we're dealing with an inverse square relation? Well, we need y and 1 over x squared, because that's what's directly proportional to each other. Y is directly proportional to this whole mess, 1 over x squared. So this graph should be a straight line through the origin. Similarly, for a square graph, square relation, what do we plot to make a straight line through the origin? Y, and what it's proportional to, x squared. So you square all of these x values. And lastly, to get a linear relationship here, you take all these x values for all the different data points, you square root each one, and you plot y against you plot y against square root of x. This is called linearizing data. We're taking a nonlinear graph and we are making it linear. linearizing data.